Hello and welcome to this session. In this session, we are going to discuss the following question, and the question says that for the given simplex table, identify the basic and non-basic variables, find the corresponding basic feasible solution, determine whether the optimal solution has been found. If not, then find the optimal solution. In this question, we are given a simplex table. Using this table, we will answer these questions. In the first part, we have to identify the basic and non-basic variables. See, x1 and x2 are the variables. S1 and S2 are the slack variables. And variable z represents the objective function. We will find the basic and non-basic variables from x1, x2, s1 and s2. We know that basic variables are those variables which have basic column leaving last row. So here x2 has basic column 1, 0 and s1 has basic column 0, 1. So the basic variables are x2 and s1. The remaining two variables are non-basic variables. So the non-basic variables are x1 and s2. So we can write x2 and s1 in the first column under the basic variable heading. Next, we have to find the corresponding basic feasible solution. The rightmost column, let us name it as the RHS column, gives the values of the basic variables. So here, according to the given table, x2 is equal to 12, s1 is equal to 15. So, from the table we interpret x1 is equal to 0, x2 is equal to 12, s1 is equal to 15 and s2 is equal to 0. And the value of the objective function is z equal to 50. Since the basic variables are non-negative, so this is a basic feasible solution. Now next we have to determine whether the optimal solution has been found or not. See the last row of the table corresponding to z. Here we have a negative value -4. So this is not an optimal solution. We can derive the optimal solution by identifying the pivot element. So we form the next iteration. -4 corresponds to the variable x1. So x1 will enter the basis. And this column will be the pivot column. Now we find positive ratio. For this we divide each entry of the rightmost column by corresponding entries of the pivot column, leaving the last row entry. We have ratio 12/2 equal to 6 and 15/3 equal to 5. Now 5 is minimum of the two ratios and it corresponds to 3. So we choose 3 as the pivot element. In the pivot column, also the corresponding basic variable to this pivot element is S1. So S1 is the outgoing basic variable. We mark an arrow here. This row is also called the pivot row. So now x1 is the new basic variable. We have to make the pivot element equal to 1 and all other elements in the pivot column equal to 0. So we first divide the pivot row by the pivot element. That is, we divide the pivot row by 3 and x1 enters the basis. So we get this table. Now we make 2 and -4 in the pivot column equal to 0. For this we use specific row operations. R1 goes to R1 minus 2R2 and R3 goes to R3 plus 4R2. So we have the following table of values. Now all values in the bottom row corresponding to Z are positive. So we are done. Rightmost column gives the optimal solution to the linear programming problem. Corresponding to x1, we have value 5 and corresponding to x2, we have value 2. So the optimal solution of the given linear programming problem is x1 is equal to 5, x2 is equal to 2 and the value of z is equal to 70. This is the required answer. This completes our session. Hope you enjoyed this session.